Can we pretend that airplanes in the night sky like shooting stars? I could really use a wish right now, wish right now, wish right now. Can we pretend that airplanes in the night sky like shooting stars? I could really use a wish right now, wish right now, wish right now.
Yeah, I could use a dream or a genie or a wish to go back to a place much simpler than this. Cause after all the partying and smashing and crashing, and all the glitz and the glam and the fashion, and all the pandemonium and all the madness, there comes a time where you fade to the blackness. And when you're staring at that phone in your lap, and you hoping but them people never call you back. But that's just how the story unfolds. You get another hand soon after you fold. And when your plans unravel in the sand, what would you wish for if you had one chance? So airplane, sorry I'm late. I'm on my way, so don't close that gate. If I don't make that, then I switch my flight, and I'll be right back at it by the end of the night.
House down. Come on, let's twist. Yeah, baby, twist. Ooh, yeah. And it goes like this. Come on, little baby, and do the twist.
From our lecture, we should remember that the tangential speed equals 2 pi r divided by t. The r is the distance from the center or the radius, and that's always going to be in meters. The t is the time or period, and that's always going to be in seconds. So from our front problem, we see that r is going to equal 30 centimeters. Now we'll convert that right to meters right off the bat by dividing it by 100. So that's going to give me 0.30 meters. Okay, so it makes one revolution every 0.125, so that's the period, 0.125. We're going to kind of plug and chug here. V equals 2 pi times 0.30 divided by 0.125. So we multiply across 2 times pi times 0.30 divided by the 0.125, and we should get a number of somewhere around 15.0 meters per second. So that's how you're going to find the tangential speed.
Of the perfect place, they got it better than when anyone's told you. They'll be the king of hearts and you're the queen of space. Then we'll fight
until the 17th century that Isaac Newton described the fundamental laws of motion, and we understood the answer to these 3 questions. What Newton recognized was that things tend to keep on doing what they are already doing. So when your bicycle is stopped, it stays stopped. And when it is going, it stays going. Objects in motion tend to stay in motion, and objects at rest tend to stay at rest. That's Newton's first law.
I have to find a new partner.
Have you talked to the second-year students?
I've auditioned a bunch of them. Ready?
I'll do it.
Are you kidding?
I was just trying to help.
Okay, wait. Catch me.
Now.
According to Newton's third law, for every action there is an equal and opposite reaction. To understand this, think about what happens when you drop a bouncy ball. As the bouncy ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction, upward, causing it to bounce back up to you. Together, the floor and the ball form what's called the action-reaction pair.
Now I want you to make a prediction. In my left hand, I have a standard-sized basketball, and in my right hand, a 5-kilogram medicine ball. If I drop them both at exactly the same time, which one will hit the ground first?
This is a trick one, isn't it? The heavy will go down first.
Well, yeah, it'll drop faster. They'll both hit the ground at the same time.
Give me a pin, though. This will be faster.
I want to be fast. Something to do with mass or something.
I can't remember why.
It's not actually weight that holds it back, but inertia. That's all that means. Well, the force on the medicine ball is greater than the force on the basketball, but it has more inertia. And what's really important is that the ratio of force to inertia is the same for all objects. So everything accelerates at the same rate and lands at the same time.
F equals g times m1 times m2 divided by r squared, where g is the universal gravitational constant, m1 and m2 are the masses of the two objects, and r is the distance between them squared. That was easy, right? Probably not. But what does this actually mean? Well, it means that, well, everything is attracted to everything else. And what I mean by that is that if you have two objects, any two objects, they are attracted to each other. Okay, let's try and wrap our minds around this. What happens when you drop a rock off a cliff? It falls to the earth, right? Well, yes, But something else happens. You see, the law of gravity says that both objects, the rock and the earth, are attracted to each other. This means that the rock falls towards the earth, and the earth falls towards the rock. Wait a second. You mean to tell me that if the earth falls up to meet the rock? Yes, that's exactly what I'm saying.
Sometimes you just feel tired, feel weak. And when you feel weak, you feel like you want to just give up. But you gotta search within you. Try to find that inner strength and get that motivation to not give up and not be a quitter. No matter how bad you want to just fall flat on your face. Till I collapse, I'm spilling these raps. Long as you feel them to the day that I drop, you'll never say that I'm not killing them. Cause when I am not, then I'ma stop pinning them. And I am not hip-hop, and I'm just not Eminem. Subliminal thoughts when I'ma stop sending them. Women are caught in web, spin them in hawk venom. Adrenaline shots, the penicillin could not get the illin to stop. Amoxicillin's just not real enough. The criminal cop killing hip-hop, filling a minimal swap to cop millions of pop listeners. You're coming with me, feel it or not, you're gonna fear it like I showed you. The spirit of God lives in us. You hear it a lot, lyrics the shock. Is it a miracle or am I just product of pop? Listen up, but sizzle my whistle, this is the plot. Listen up, you pistols for God, Slizzle does not give a fuck.
Comes off, till the lights go out, till my legs give out, can't shut my mouth, till the smoke.
Acceleration. Acceleration. And this is probably an idea that you're somewhat familiar with, or at least you've heard the term used here or there. Acceleration is just the change in velocity over time. The Porsche 911, they'll literally measure it with a stopwatch, can go 0 to 60 miles per hour, and these say 3 seconds. In 3 seconds. So the acceleration, and once again, acceleration is a vector quantity. You want to know not only how much is velocity changing over time, you also care about the direction. It also makes sense because velocity itself is a vector quantity. It needs magnitude and direction. So the acceleration here, and we're just going to assume that we're going to the right, 0 miles per hour and 60 miles per hour to the right. Change in velocity. This delta symbol right here just means change in velocity over time. We could just write time here. This change in velocity. So our final velocity is 60 miles per hour. Our final velocity is 60 miles per hour. And our original velocity was 0 miles per hour. So it's 60 minus 0 miles per hour. And then what is our time? What is our time over here? Well, our time is, or we could even say our change in time. Our change in time is 3 seconds. 3 seconds per hour. And then we could either put seconds like this, or we could write per second. Per second. And let's just think about what this is saying. Then we could get it all into seconds, or we could all get into hours, whatever. Or 1 hour is equal to 3,600 seconds. And then you multiply. Do a little dimensional analysis. Hour cancels with hour. And then you have, this will be equal to 20 over 3,600. 20 over 3,600 per second squared.
She's all laid up in bed with a broken heart.
You're gonna get run over.
By all the cars?
Dad and I used to come out here and lay down and watch the lights change. Watch them go from green to red to yellow.
You could try it if you wanted to.
No.
Why not?
Because, I don't know, we just get up.
That's your problem. You know that? You don't do what you want.
Okay. And what happens if a car comes?
You die.
What?
Just relax. Just trust. You need to learn how to trust.